corner, you see a picture that shows the effect of pH and cotton root growth. And as you can see, as the pH decreases, there is a reduction in root growth of the cotton plant. In the lower left picture, you can see that as the aluminum toxicity decreases, the root growth increases. And finally, on the right side of the screen, you see a picture that it's actually divided in half. On the left side of that picture, you see less weed, and on the right side of the picture, more weeds in the turf. And because one side, the left side, actually received amendment prior to a year before taking this picture. And Dr. Warrendick will talk more about soil amendments, in particular gypsum, after this section. So for our long-term experiment that we're currently conducting at the OARDC, we have 4 soil amendment treatments that will be applied. Our treatments include limestone and Greenfield Farms cooperative proprietary amendment and a control.
They didn't say they wanted
we will also rotate our 4 crops, which are corn, soybeans, cover crops, and our experimental design is a randomized complete block design with 4 treatments and 4 replications at 3 locations. The plot sizes are 20 feet wide and 40 feet long each. Just finished a few months first year of
how you doing, members? Do we have Michelle
data
log out?
collection,
And if she will,
hopefully in a
I'm
few
6
months,
for
start our second year data collection.
Thank you.
With that, I'm finished with this section, and I will hand it over to Dr. Warrendick. There you are, sir.
All right, and while you need to get my presentation on. What I will be doing in my few minutes is basically talking about gypsum and giving a primer on gypsum and how it's used and some of the benefits. So this is titled Research and Practical Insights into Using Gypsum. So I've stolen a few slides from Stephen Weller from Purdue just to get started. We need to talk about what is a good quality soil. And those are some of the features that you see listed there. It's soft and crumbly, it's well drained, resists erosion, it takes in water easily, it has a diverse population of soil organisms, it holds nutrients, free of harmful contaminants. So that's a good quality soil. A poor quality soil, of course, is basically kind of opposite. It's compacted, it has poor aeration, it's hard to get air to the roots, has low nutrient holding capacity, low organic matter, lacks a diverse population of soil organisms. And as a result, it restricts root growth. And roots are a good indicator of soil quality. So some thoughts about soils and weeds. Weeds are a symptom, as Dr. Mosen has said, of soil problems. They can give insights into the soil. Knowledge of weed indicators can allow modification of soil management practices, and soils, when properly managed, will grow better crops. The crops can compete better against the weeds and thus lessen the influences of weeds. So I have a crop are wimpy. You know, we have bred crops to have higher yield, but not really to be competitive very well. So we need to help out our crops many times to be competitive against weeds. So what is gypsum? So this is the story about gypsum where I'm going to start. It's calcium sulfate with 2 waters. It's a soft mineral. If you go to any sort of mineral museum, you'll see all kinds and shapes and colors of gypsum. And you see some here from Australia, gypsum powder. Burnt gypsum, which was first used in Paris, is often called plaster of Paris. But one of the things about gypsum, it's moderately water soluble. About 200 times more soluble than calcium carbonate or lime, and so that's a thing to remember. It has a long history of use in agriculture, so it's not new. The Greeks and Romans used it. It was used in Europe. In the 18th century, men that were working in the plaster of Paris production, when they would come home, they would have this dust on their clothes, and the wife wouldn't let them in the house at night with all that dust. So they would make them shake their clothes outside of the house, and they found that wherever they shook the dust off their clothes, the grass was greener. And this was one of the observations that was recorded even back then. And so it had extensive use in Europe in the 18th century. I have this publication actually in my office, and if anybody wanted to send me email, I could send it to them. It's a history of use of agricultural gypsum that was published in 1922. It's a really fascinating story about the use of gypsum in the early colonial period of the United States and even beyond. For example, he tells the story of Benjamin Franklin, who was one of our great American scientists. And he commissioned and actually conducted several studies on gypsum, and he spelled out on the side of a hill in letters using gypsum, "This hill has been land plastered." So when farmers would drive by in their buggies or horses, they could read that, and it was a natural advertisement for the use of gypsum, which other than manure was really the only land amendment material that was used in those colonial periods. At that time, the gypsum came from Nova Scotia. So I'm going to talk about the 5 benefits, the major benefits of gypsum in the next few minutes. And so I'll look at each one of these individually, but these are the 5. So let's just start with that first one. Source of calcium and sulfur for plant nutrition. Gypsum is about 22% calcium and 18% sulfur. And we often forget that both calcium and sulfur are macronutrients. Every university, land-grant university in the country studies NPK, but we have forgotten about calcium and sulfur. But they are making a comeback. There's more and more interest. And one of the reasons is this. As we have cleaned up the air because of the Clean Air Acts passed by our Congress, we're not getting as much sulfur in the rainfall, which used to be free onto our land. You can see the soil test values for sulfur from 2002 to 2014. There's a straight line downward. And the literature says we should start seeing a response to sulfur at about 10 parts per million. So you can see we're below that or near that pretty much from about 2010 on. So that's one reason there's more and more interest in using materials like gypsum. We have done some work here at Ohio, at Worcester, from 2003, looking at corn yields. We applied gypsum as a sulfur source. We got a very significant yield advantage to that amendment, to that addition. Similarly, for forages, and especially it seems like alfalfa, almost every time we do a test with alfalfa, we see a significant response to the sulfur and gypsum. Again, we see a very significant response here of adding gypsum to alfalfa fields as far as increasing yield. But not only does it increase yield, it also increases forage quality. Study that was done in Scotland. So if you look at sulfur on the left with, no sulfur on the left with no nitrogen, the daily sheep gain was about 100. Add a little bit of nitrogen to the forage. As you grew the forage of the alfalfa, the quality went up a little bit. Sheep gained a little bit more. But the optimum gain for the sheep was when you had both sulfur and nitrogen. And the reason is you need sulfur and nitrogen both to make protein. And if either one is missing, you really don't get that high protein quality in your forage that you would like. Second is gypsum is a source of sulfur and exchangeable calcium to ameliorate subsoil acidity and aluminum toxicity, and that has already been introduced a little bit. So what happens, you apply the gypsum on the surface, it reaches downward because it is somewhat soluble. It displaces the aluminum 3+, which is really the toxic form, and restricts the root growth. Some of the sulfate can also complex with that aluminum, which forms an aluminum sulfate complex. That is not toxic to plants like the aluminum 3+ is. The result is increased root growth. So here's a little example of that. We have at the surface gypsum calcium sulfate. We have down below the aluminum. because the soil is acid, and in acid conditions, the aluminum is more soluble. But I want to say one thing before I move on this talk, which is a very big misconception. Gypsum is not a liming material. It does not change pH upward. In fact, if it does anything, it will reduce the pH a tiny little bit, 0.1, 0.2 units. But it does make the soil, even an acid soil, more friendly for root growth because it displaces the aluminum. And so here we see the gypsum on the surface. We apply it, it solubilizes and moves down through the profile, displaces the aluminum, kicks it out. The aluminum is leached out. Some of the aluminum forms complexes with the sulfate, and that sulfate complex is non-toxic. And so the net result is improved root growth. Here's a typical pH profile of a bound soil in Ohio. If you line the surface, the pH is about 6.5, which is really nice for growing crops. But you go down to about 30 to 40 centimeters, that's about 8 to 16 inches. You see the pH drops below 5 and aluminum 3+, becomes much higher in concentration. It's toxic. And so that restricts root growth. All the roots will be in the surface. So here's an example of roots where we've been treating with gypsum. You can see if we only treat with limestone, all the roots are in that top 20 to 40 centimeters. And it goes down very quickly because the roots don't like that acid subsoil. If you apply both limestone and gypsum, which is usually what I recommend, you need both if you have an acid soil, you can see how the roots proliferate much greater, even at depth. If the roots are going deeper, they can get more water during the droughty periods and also can explore more soil volume for the nutrients, nitrogen, calcium, phosphorus, sulfur, all those other nutrients that a plant needs. A third benefit, it fluctuates clays to improve soil structure and reclaims high sodium and high magnesium soils. Flocculating clays just means we take individual clay particles and bind them together to make micro aggregates. So here we see some clay particles. Magnesium binds with water to make a very high hydrated ion. And because magnesium with water is very large, it pushes the clay particles apart and they're dispersed. And when rainfall occurs, all those individual particles begin to move into pores. They eventually clog the pores, causing crusting and pore infiltration. Calcium does just the opposite. It's got two charges just like magnesium, but it doesn't have nearly the large hydrated radius, and it tends to bind clay particles together and make these micro aggregates. So this is what happens here at Worcester, for example, our silt loam soils. If we get a heavy rain in the spring, we can get crusting, even though it's a silty soil. And more than once over the 35 years I've done research here, I've had to replant soybeans because of crusting. Calcium will help reduce this problem. And there's been a lot of research, not only here in Ohio, but in cotton fields in the south and other parts of the country to look at this issue. It also improves water infiltration. So if you put gypsum on the surface, it helps keep the soil open. It's like keeping the valve of the soil open for the water and air to go in. You can see a very significant difference between infiltration rates where we've applied gypsum and where we did not. And this is an aerial view that was flown by Dr. Darrell Norton of USDA near Indiana. Two fields right next to each other after a heavy rain. The one on the bottom left had been treated with gypsum. You don't see any ponded water. And the one towards the top, you can see ponded water in a number of different places. And this is one thing farmers continually will tell me, that when they add gypsum to their soils, their infiltration and just the whole hydrology of the system changes. So base saturation targets, these are some of the things that have come up. I'm on a committee with a number of other scientists from USDA and universities. And we're coming out with a gypsum standard, a national standard. I just have two slides to kind of review some of the basic things in that standard. Target ranges for base saturation of cations to improve soil chemical and physical properties. We want calcium to be in the 70 to 80% of the total cation exchange capacity. Magnesium about 10 to 13%, potassium about 2 to 5%, and hydrogen about 1 to 10%. Now, in soils that are sandier or more droughty, we want to have magnesium at the higher end and calcium at the lower end. At the higher clay soils, we'll have calcium at the higher end, just the opposite, and magnesium at the lower end. And so gypsum application rates to improve soil chemical and physical properties. These are some of the rates that are being recommended to change that. These are higher than what you would use if you're using gypsum only as a sulfur nutritional source. But if we're looking at for base saturation, soil balancing, changing the soil for chemical and physical properties, we say if the CEC is less than 5, maybe about 0.25 ton per acre. If the CEC is larger than that, all the way up to greater than 15, we'll recommend 1 to 2 tons per acre. And that can be adjusted every year based on soil test. Number 4, promotes calcium humate or organic matter formation in soil. Soil scientists have known for many, many years, I would say maybe 100 years or more, that calcium acts as a bridging cation to help build organic matter in soil. There's some really nice recent work out of Brazil, actually, that details some of this. But I just have one slide to illustrate this. We have at the bottom on the right there a clay bundle or clay platelet, and you can see the oxygen are in red, and then the silica and the oxygen, and the other cations, aluminum, magnesium. So that's a clay surface, and on the top of that is this humus material. And what calcium does, it acts as a bridge to bind the humic material to the clay and stabilizes the organic matter in the soil. Of course, the other thing that calcium does, and I've already mentioned it, it makes these microaggregates, and as those microaggregates are formed, it traps organic matter in those aggregates. And that's another way it enhances soil organic matter concentrations in the soil. And then the most recent one that has received a lot of attention in the last year is gypsum can be used to improve water quality. These are some pictures that we took in the last, just a little over a year ago, 2 years ago I should say, where we applied gypsum over different tile lines. And the picture on the left is where we had no gypsum over a tile line, and just the adjacent tile line next to it, we applied gypsum. You can see very clearly the difference in water quality just visually. And the samples on the top right there, again, you don't need any fancy equipment to see the difference. It's very, very clear just by your eye, the difference it makes. This is from another farm, January 2013, no gypsum samples versus gypsum samples. Again, very clear differences. Work done by USDA on artificial rain-making machines. They rained on soil to control without gypsum. You had more runoff because you had less infiltration. When you have more runoff, you have more erosion. And so gypsum reduces the erosion, keeps the soil on the field, which is where you want it, because usually the soil that erodes is your best soil. And so if you can reduce erosion, that's always a good thing. And then the soluble reactive phosphorus, SRP, declined more than 60%, about 66% actually in this study. This is a Ohio State University Extension Bulletin. If anybody is interested, I guess you can see these slides afterwards, but you can get this bulletin or you can send me an email. I'll send it to you. A lot of information, very similar to what I've just said right now. Also at the national level, I think it's interesting to just point this out. When I started working on gypsum a number of years ago, people were saying, well, that's kind of crazy. And now we have a national academic group from the American Society of Agronomy looking at gypsum in agriculture. I think there's maybe like 80 or 90 researchers that are involved in this. So it's really become a very important Gypsum as an agricultural amendment can provide multiple benefits, including improved crop production via inputs and better soil quality, and it also improves water quality. This leads to a win-win situation. Thank you.
We have a couple questions from that section. The first of which, would you add this gypsum to undisturbed soil or after a plowing?
You can do both. If you're doing actually I like to put it on the surface if I can, but if you can mix it in, it doesn't negate the benefits that you will capture from it. But my preference would be to put it on the surface because it's your surface that really controls infiltration and aeration. So I have seen both used, both work, but if I have my preference, I put it on the surface.
All right. Application methods for small gardens.
For small gardens, even on our research plots, we just hand apply it. Try to do it very evenly across a plot, across a garden. Very easy to do. You can use it with a lawn spreader, yeah. You can buy gypsum at your garden supply store. It's usually found there very easily. And there's no special magic of how to apply it.
And with some of the charts that you show, will there be descriptive notes available at some point?
I haven't done that, no. I think if people want to ask me questions, I'll respond to questions.
Okay, and all right, now this one has three parts. If the soil is deficient in aluminum and it's unable to bond with the gypsum, would it bond with other elements? And if so, would those combinations be toxic?
Usually we never worry about soils being deficient in aluminum. The lower the aluminum 3+, the better. You know, what happens as the calcium moves downward, it will bind to exchange sites, will displace some of the other cations, but it's not really an issue as long as you keep testing your soil and you don't go out of those ranges that we mentioned in that table as far as cation exchange capacity ratios, amounts. So you don't want to go above 80% of your total cation exchange capacity being calcium. But as long as you stay in those ratios, it really there's no issue about aluminum and calcium interactions at all.
And would you consider gypsum safe and appropriate for livestock pastures?
Yes, it is, but what we say, and I'll tell a little story here in a little bit. When you apply gypsum, I would keep the cattle out until after a rain to wash it off the leaves. They like the taste of it. We had a story out of Indiana where a farmer had a stockpile of gypsum. He didn't have it fenced off from the cattle. The cattle got into it. They really ate it up a lot. They loved it. And in their rumen, it's anaerobic. It turned to hydrogen sulfide, which can be toxic. And actually 2 cows died. So, you know, like anything else, a little bit is good, too much can be bad. Almost anything in life is like that. And so if you apply it on forages, actually the best time to apply it onto a forage field is after a cutting. If you apply it to a pasture, I'd keep the cattle out until after a rainfall.
Okay, our next presenter will be Dr. Laura Lindsay from the Ohio State University, and her screen is now being shown. So I'll turn it over to her. Thank you.
Okay. Laura actually couldn't be here. I'm Aaron Brooker. I'm one of her graduate students, and I'm going to talk a little bit about the impact of on-farm research. And okay, so what is on-farm research? It's small plot research on farmers' fields or large plot strips on farmers' fields using standard field equipment. And then it can also be data collection without imposed treatments. And we're actually doing a study right now on soybean yield limiting factors throughout Ohio that would be this last one. It's data collected without these imposed treatments, and the farmers really don't have to do anything except give us information on what they've done with the field, and we come out and do soil samples, tissue samples, and other stuff to get our data. So why do we conduct on-farm research? Some situations can't be easily replicated at research farms, and it gives us a better understanding of what is going on in the real world, and it allows us to engage and connect with farmers. A lot of our information comes from just talking with the farmers. We can learn a lot from talking to the farmers, so this gives us a much larger opportunity to do so when we're actually going out to the farms. So, like I said, our current on-farm work, we've sampled over 140 growers in 2013 and 2014 to identify yield limiting factors in Ohio for soybean production, and data we've collected includes weather, soil fertility and physical properties, plant nutrition, and pests. This includes soybean cyst nematode, weeds, insects, and diseases. So we're really getting a look at everything that goes into the production. We're also getting a survey of management practices that gives us a good idea of what farmers are doing as well. So this gives you a picture of the sampling regions that we chose for the fields. Each field, we take a sample for 2 normal yielding areas and 1 low yielding area to kind of pinpoint where the problems are and what could maybe be causing problems. And so far, the impact of this research has shown us that throughout Ohio, 1 out of 4 soil samples have been low in phosphorus. This is pretty important because we always hear about the negative side of phosphorus, how it's causing all the problems in the lakes, and it's actually pretty important to know that some farmers do actually need phosphorus. So also 1 out of 10 soil samples has been low in potassium, and 1 out of 5 soil samples has had a pH of less than 6. 6 to about 6.8 is the range that we want to see for soybean production. So this also needs corrected. And 55% of the soil samples had detectable soybean cyst nematode. And when surveyed, most farmers were unaware of the soybean cyst nematode in the fields. And one thing another graduate student is also working on is identification of the potential new pathogen, the pin nematode. We're not sure if this is pathogenic to soybeans or not, but that's something we're working on. So this is an example of what would be returned to the farmer. You get a map of your field with the 3 different sampling locations, and each of those 3 this would be from a soil sample. You'd get your texture, organic matter, pH, buffer pH, and your phosphorus and potassium cation exchange capacity, and this all goes back to the farmer. All the information we collect from the field, we send back to that farmer too. So our current work, it focuses on conventional soybean farmers and is funded by the Ohio Soybean Council, and again focuses on yield limitations for soybeans. The proposed on-farm work would focus on organic growers, grain farmers for soybean, and vegetable farmers, and it focuses on factors that impact yield with a close look at the base cation saturation ratio. And that's all I have.
All right, there were a couple questions.
Okay.
Do you consider that cation exchange capacity research will be compromised if boron is deficient below 1 part per million or less than 1/1000th of the calcium?
Well, unfortunately, Laura is not here, and I don't have an answer for that question. So I'm sorry I can't answer that.
All right, we'll move to the next. Do you find similar issues when comparing organic farm soils to conventional farm fields?
And again, I haven't actually worked with that. Laura would probably have a better idea, or one of the other panelists might have a better idea. I haven't personally worked with that very much, so I don't know.
All right, next question is, how are you determining low phosphorus levels?
So the low phosphorus levels, we go out and take from our from each of the 3 areas, we take a soil sample from each area, and we get the parts per million of phosphorus back from that. And then from the Ohio Tri-State Fertilizer Recommendations, there is a deficiency level, or a level of 15 parts per million that you don't want to be below, and we just go by that level. That under that, you're low in phosphorus. So based on the soil samples that we take.
All right, thank you. Our next presenter is Dr. Matthew Kleinhentz. He is next one up. Thank you.
Thank you, Eric. As Eric just mentioned, my name is Matt Kleinhentz. I'm with the Department of Horticulture and Crop Science. I am based at the OARDC in Worcester, Ohio, and I'm very, very pleased to share this time with you, and pleased that you've joined us. I know that we have in the neighborhood of 100 people on the line with us this afternoon, and that's a terrific number. And you may have questions that you're not posing at the moment, but we do encourage you to send them along. As Eric mentioned up front, we will do our best to answer them after the fact, and certainly we will do our best to answer them right here. There were 2 questions posed earlier that I'd like to try to address in part before we get into the next section very briefly. The first question had to do with there not being a counterpart for aluminum. If free calcium was moving through the profile, would that be problematic? At least from my experience, some of that free calcium would be available for uptake by crop plants, and there are a number of benefits that follow from that. So I too, like Warren would say, I'm not worried about a lack of aluminum to bind to the calcium moving through the profile. And Eric, just in the most recent presentation here, there was a second question. Would you be able to repeat it? And perhaps we could address it here before we move forward. Do you happen to recall what that question was? Would it be compromised by low boron? Is that the question? Oh, comparison of organic and conventional. Well, certainly most of the folks here around the table, and many others within the college, have worked in both systems, including Laura. And I would venture to say that the answer is a case-by-case basis, depending on the comparison. But in my experience, I would imagine this BCSR, or soil balancing, to apply to both very, very well. But again, we can follow up as needed as we go forward. So Mosin gave us a very solid overview of soil balancing and its basis, if you will. And he described some of the follow-on effects that can occur when soil balancing is adopted, and those effects having first been identified by farmers and then brought to the research community. That was followed by Warren's presentation on gypsum and the 4 to 5 major groups of benefits that its application can offer. And then Erin just provided us with a very quick summary of some of the on-farm research that her program leader, Dr. Laura Lindsay, is orchestrating, involving primarily soybean farmers, but not exclusive to them. My job in the next 10 minutes is to provide you with a summary of the on-farm research that we anticipate conducting through the BCSR project. And I think the screen has been locked here temporarily, and we can get on to the next. There we go. Okay. So the roadmap for the next 10 minutes is to describe in very general terms on-farm research that has engaged Ohio farmers, Ohio scientists, and educators through the years. Our second objective is to outline an exciting OFA-OSU initiative that will help Ohio organic farmers through on-farm research specifically. The third objective in the next 10 minutes is to clarify how you can participate in that initiative. Should you be able and interested, there are definitely ways for you to contribute to the effort and learn from it and gain from it. And then finally, we would like to answer any questions that you have, and of course, we do have a few questions to pose to the group at large as well. On-farm research through the years involving Ohio farmers and Ohio State University researchers can be typified in the three adjectives that you see here. First, enormous quantity of work has been done through the decades, involving hundreds of small to large projects and over many decades of time. There has been a very close connection between Ohio State University and Ohio farmers for many years, and some of those connections have involved ambitious and very helpful on-farm research. The second way to describe this on-farm research is diversity and all of the parameters that you see listed there. There have been many issues and topics addressed at many scales, in many different types of systems, in many locations, and in many settings, such as indoor and outdoor production, many farmer and university types of expertise, and all levels of farmer involvement, like you heard Aaron describing a few minutes ago, to simply hosting the collection of data or samples from the farm, to being present at the table when the hypothesis or question is being shaped, and have that hypothesis be very much directed by a farmer or groups of farmers. So a tremendous diversity of on-farm research through the decades. And the third way to describe this on-farm research is impact. This collective effort has led to many different types of improvements in farm management and in our collective understanding of farms and the natural environments in which they operate. And of course, this is a bit of a threadbare description of this tremendous amount and diversity of on-farm research, but I thought it would be appropriate to preface what I'm going to say about the soil balancing on-farm research that is planned with a bit of historical perspective. And because of that diversity and that impact and that quantity of research and the long-term connections that Ohio State University and Ohio farmers have had, OFA and Ohio State University think it is a prime time, it is a perfect time to form what we call the Organic Growers Research Network. And this is an OFA-OSU collaboration. And the purpose of this collaboration is to enhance our communication, to match our respective needs with our respective capacities, because farmers and researchers have different capacities, and when they're combined, it can be a much more powerful relationship than operating individually. And when we combine those capacities, we're very much in a position to learn from each other. We're very much in a position to empower each other. Ohio State being able to help prepare farmers to take additional steps in their operation, which will eventually lead to improvements in their bottom line. There's no other objective than that. Now, specific to the so-called soil balancing research that we have been alluding to here today, soil balancing at its core, as you probably know, is a chemically triggered improvement in crop production and soil health. We begin with some form of application to the soil, for example, gypsum and limestone. We change the chemistry of the soil fundamentally. The change in the chemistry of the soil leads to changes in its biology and its physical properties. Chemistry, physics, physical properties, and biological properties all come together in the soil. And with soil balancing, we're trying to improve the entire status of the soil through natural chemical manipulation, if you will. And that whole process is being carried out today and on working organic farms and non-organic farms in Ohio and across the region. And of course, it's the objective of this team to learn more about that. So through the soil balancing research that is within the Organic Growers Research Network, we aim to recruit and collaborate with 50 Ohio farms over the next 4 years. The general expectations of those farms would be to host plots and possibly an educational event or events, such as a farm tour where other farmers are come to visit the farm and discover what is being learned there. We'd also would hope that the organic farmers participating in the network would be willing to share their insights and some information, which I'm emphasizing in the slide here, is always confidential. I would have put 5 more exclamation points if it would help to convince people that it will be confidential, but that is the actual fact. It is confidential. The benefits of participating in the research network are many, but some of them are illustrated on the slide here. The first and perhaps most important benefit to a farmer in participating in the network is that they have a direct impact on the research that is done. They will shape the research directly. They will not be a standing by witnessing the research. They will be shaping the research. They will then, of course, be able to gain firsthand, quote, early adopter experience through participating in that research on their farm. Thirdly, they will help other farmers now and later because they are willing to step forward and offer their farm as a research site and to share information and insight and to gain some of the information and insights, of course, from the research team. They will be able to then share that collective experience and knowledge base with other farmers both now and later. And through that entire process, they will also be in a position to enhance their own research skills. I think everyone around the table here and within our college understands how sophisticated and significant farmers' own research skills are. They are tinkerers by nature, of course, farmers and growers. And through this collaboration, through participating in the research network, we would hope as members of the college, Food, Ag, and Environmental Science, that we can enhance the inherent skills that farmers have in conducting research on their own farm. So how can you help out? How can you get involved? First and foremost, you'd want to share your interest with OFA. And that person I'm nominating here is Eric. Eric is our moderator this afternoon. If you don't know Eric, he can be contacted at the OFA office, and his contact information is online. We encourage you to reach out to Eric if you are at all interested in this Organic Grower Research Network. Your first points of contact will be OFA, and that's important to note. Second step that you can take is to clarify aspects of that collaboration that are important to you. This is not a one-size-fits-all approach. For example, you may want to say, I'm interested in the network, but it's just not something I can do this coming year, but I could definitely put me on the docket for next year. We would like to learn that, and Eric, I'm sure, would like to learn that as well. You may also wish to say something like, well, I'd like to share information and insights, but not my land. I think I have something to offer to the research team in terms of my experience and my understanding of soil balancing and soils and organic farming, but I'm just not in a position to host research plots on my land. We would still like to hear from you. You can still participate and contribute to the overall effort, even if you do not host plots. And a third way that you can get involved and really help the effort and really grow this collaboration is to get the word out. Tell a friend, tell a family member, tell a business associate. Start the chatter, start the conversation, start the discussion. Let other people know that the Organic Grower Research Network is forming, that OFA and OSU are very serious about this collaboration and about this initiative, that it is beginning with soil balancing, the Basic Cation Saturation Ratio project, but other projects and other issues important to growers will follow. But it is important for all the organic growers in Ohio, I think, to be familiar with. And just to clarify one additional detail, Aaron mentioned a number of minutes ago that this project will include soybean and grain farmers and vegetable growers, and that is absolutely the truth. So as far as questions that I would pose to you, and Eric, I don't know, I haven't seen the monitor, so I don't know what questions might be coming through. I'll be glad to address those before turning it over to Doug. But the 3 questions that I would like, and other members of the team, team would like to pose to the group that's online with us right now is, these questions are: would you like to know more about soil balancing? You can answer that yes, no, or be more effusive in your answer. Would you like to know more about the research network or on-farm research? And will you consider hosting research on your farm? If you are willing to use your chat option within your connection now or in the next few minutes to answer those questions, we would be very happy to receive the answers. Of course, everything is confidential, and this does not commit you or bind you in any way, shape, or form to your answers, just that we are looking for a first cut response on those 3 important questions. But Eric, I'd like to, at least for the moment, turn it back to you to see if there are any questions about what I have said before we transition to Doug for the wrap-up.
Yes, Dr. Kleinhans, we have a number here. What extractant will be used for the soil test?
That's a good question. I wish my colleague, Dr. Steve Coleman, was here to help answer that, but maybe Warren can. I'll give a first cut answer and then turn it over to Warren. My understanding is that standard operational procedure will be used to extract mineral nutrients from the soil. We've had a very long discussion on that topic as a team, involving growers and other members of the industry community, and all agree that we have to be able to compare apples to apples. We have to compare soil test to soil test, farm to farm, year to year. So we need a very consistent methodology, and right now, to the best of my knowledge, that consistent methodology is already in place at most of our commercial labs, but I'll turn that over to Warren.
Well, there's a number of ways to do that, and on our more commercial farms, we use the traditional ammonium acetate displacement test to measure cation exchange capacity, and then whatever cations are displaced, such as calcium, magnesium, potassium, they are measured in that extract, and then we obtain our ratios from there. I have heard people say they want to use soil paste, other types of procedures. So I'm more of a consultant to this project at this point. What will actually be used is probably not going to be my decision, but I know in all of our other research we've been primarily using ammonium acetate.
Thank you.
So stay tuned. Whoever might have had that question, definitely stay tuned and follow up with a member of the team as needed.
All right, would you consider gypsum applications beneficial for all vegetable crops?
I have an opinion. I would say I don't know of a circumstance in which they would not be beneficial. I had to chuckle at Warren's, one of his last slides, the historical perspective with now the movement of the Agronomy Society and recognition of gypsum's importance. My own research in the early 90s involved gypsum, and people at the time thought it was a little bit wacky, but we were applying gypsum as part of our regular program in potato production, and seeing benefits from that. And Warren's presentation today, now some 20 plus years later, makes me want to go back and look at those data again for why we were seeing the response that could have very well been about root growth.
The other thing I will say, this is Warren, gypsum, and especially the calcium, there has a lot of benefit as far as quality of the produce that is grown on the soil. But the other thing I always say is you want to make sure that you test your soil, because like anything else, and I already mentioned this, too much of a good thing can be bad.
Yes.
And you can get out of balance if you just think, well, if I apply 1 ton of gypsum this year and it was good, I'm going to apply 2 ton next year.
Right.
So you have to make sure that the soil is telling you what you need, and that's very important.
Right. So my better answer should have been what Warren just said, which is, I have not seen the circumstance where it was not, all beneficial in all cases when properly done.
Thank you. Will the cation exchange capacity numbers be inflated if the soil pH is greater than 7?
That's a good question. Of course, greater than 7, you'll have carbonates, calcium carbonates, And normally, a lot of times what we do is we get rid of those carbonates first before we do a CEC. But it does make it a little trickier when you have carbonates in the soil. And that's an area, frankly, I would like to have more knowledge about. You know, what are the benefits of gypsum on a high pH calcium carbonate containing soil? And like I said, there's literally hundreds of man-years of research on nitrogen, phosphorus, and potassium. We are just in the infant stages on learning of some of the benefits and soil interactions when it comes to calcium, sulfur, and some of these other things we're talking about.
All right, I've had a number of questions about status of certification. Are we only looking for certified organic farms, or can other farms apply?
Other farms can apply.
Thank you.
Certainly, and you mentioned, Eric, you mentioned up front that the work that we have been discussing that we're very excited to be launching into is being supported by the Organic Research and Extension Initiative, the OREI program of the USDA. And I think the program recognizes, you know, the importance of certification without question, and so do we, and so does OPA. We also recognize that if one is aspiring to become certified, that should not, but you're not yet, that should not be an obstacle to your participation in this work.
Do you recommend any testing labs, especially for high tunnel production?
Well, what I have been recommending recently is a credible lab that is part of the national network of accredited labs that must, be evaluated periodically for their methodology, and that methodology is found to be reliable, consistent, and up to standard, much like you will have UL labs, UL listed, for other products and so forth. So first and foremost, I prefer an accredited lab. Second, I prefer a lab that will work with the client to achieve an interpretation of their soil test result, if that is needed, if you're not working with, say, Extension or somebody else. Work with the client to help them understand what the values truly mean to their production system. Third, there's the subject of cost. Will the soil sample analysis be priced such that it will not be an overall deterrent to it being done? And I'd like to go sidebar real fast on that topic. Soil testing is a tiny, tiny, tiny fraction of overall production costs, but it can yield enormously important benefits. So nearly any credible lab will not be priced inhibitory. The fourth criterion would be, do they have a history of working with other clients that represent that soil or that production system, and high tunnels were mentioned here specifically. The number of labs testing for growers using high tunnels is small but increasing. So I would seek one out that has a history of working with those types of soils.
All right, when adding amendments to the soil as recommended by the soil test, how long for delay will you have before recognizing results on the clump?
Tremendous variation in that in my experience, and I'm sure Warren can add very richly to this. It will certainly vary with major factors of the system. One, what was added. We have fast-acting lime. We have slow-acting lime. We have pelleted and non-pelleted types of quote amendments or fertilizers. We have some that break down very rapidly, some that break down not so much. They're applied in the season before the cropping, in the fall before the cropping season, or at the time of cropping season. So, and then there's moisture involved. So, difficult to say with certainty how quickly, what the interval will be between application and effect. But some effects are more or less immediate, and some are not going to show until many months later.
What sort of training will be provided to cooperating farmers?
Oh, great question. Very glad to have that question. Training in this case would involve assistance in experimental design. So in the case of, we heard Mosin talk about the experimental design of the research plots that will be used here in Worcester, and we heard Aaron reference the types of plots or designs that have been used in their research. In this particular case, some of the training that will be provided will include descriptions of how to lay out an experiment so you can obtain reliable results. That's one a very important type of training. Second type of training would involve, or will involve, interpreting the results. We have comparisons. We have controls against treatments. What type and what level of consistency of difference must occur before we can believe the results, if you will, to be true and not misleading us. So overall, I would say it's in the layout and the application, the conduct of research, and then it will be in the interpreting of the results.
Okay, I believe our next presenter is Dr. Doohan.
Yep. Well, I'm going to be short and sweet. Eric, thanks for facilitating the program this afternoon, and I want to thank each speaker who presented, and excellent presentations, I thought, by all. And I also want to both thank and acknowledge all of the people who are participating in the webinar this afternoon. We fully expect to learn together in this project over the years to come. We don't consider ourselves to be the experts on organic farming or on soil management necessarily. We know a lot about certain disciplines, but we know that you as farmers have a great deal of experiential knowledge, and we are excited about the opportunity to interact with each and every one of you. We do strongly encourage you to participate on this important project that has both been identified as something, it's been identified by organic farmers in the region as something that's really very urgently needed, as well as a project that there's a lot of expectation will really help both organic farming and sustainable farming as well. So as Matt earlier said, we would like you to work with OFA and self-identify your interest in being part of this. Matt posed 3 questions, each of which we would like to hear about your response to. Thank you for the time that you've had this afternoon, and as again, as several of the speakers have alluded, if you have additional questions, please post those questions, and we are committed to doing our very best to answer each and every one of them. It may take us a little while to get to everyone, but you will get a response from us. So we look forward to meeting many of you over the months to come, as well as the years to come. Have a great day, and take care.
All right, I'd like to thank our presenters from The Ohio State University, and please contact me at eric@oeffa.org if you are interested in participating in this research. This webinar will be archived and available on the OFA website and the OFA YouTube channel. All right, appreciate your attendance. Contact me at your convenience. Thank you.